Today, I'm going to tell you guys about Kwil and the infrastructure we are building for composable data. And so first, to kind of dive into this and where exactly Kwil, which is a relational database, fits into the stack, I think it's important to really understand the different infrastructure primitives that are at play here. And I'm not going to spend too much time on this because I think most of you probably know this. But to start with smart contract platforms, these essentially allow you to build arbitrary business logic. You can deploy code, you can interact with it permissionlessly, and it acts as a protocol. And you can build interesting things like tokens and liquidity pools and bonding curves and whatever else you like in that. And that's great. That's, I think you all probably understand that one. And then what you probably also understand is arbitrary storage. And this is where Arweave and the Permaweb really comes into play. This is very valuable. So we essentially we can pay once, we can store any amount of data, whether it is a tweet or whether it is all of the data within a data center. We can put it somewhere and we can be pretty sure it's going to be there when we come back for it. It might not have tons of fancy tools for looking through it and sorting it, at least not at the base layer. But that's actually a good thing, because that's what allows it to be essentially limitlessly scalable, and that's why we don't get things like fee markets that kind of come up and bite us from behind when we're really trying to scale. And so this simplicity of just arbitrary storage is a real key unlock, and it's what allows Kwil to build more complex and more, I would say, targeted infrastructure on top of that. And so what Kwil is building, it's called a relational database, and you might also have heard these referenced as a SQL database. And so how SQL databases work is they store data in tables. You can sort of think of it like an Excel spreadsheet. There's rows, there's columns, you can have several tables, and you can mix and match these tables. They can be massive too. They can be terabytes in size, and you can cut them up and you can merge them together and do all sorts of interesting things with them to find interesting results and create interesting views on top of these tables. Because this is let's say a hypothetical use case of Kwil that involves several different applications, just like how applications on Ethereum are usually interacting with many other applications. And so in this example, just to real quickly go through this, we have in the top left, it's a table that is representative of wallets. And so pretty straightforward. You have a wallet, you have an address, and this is representative of a user. It's used for authentication. We're going to move to the right here. I assume you probably cannot read that, but this is a social application. You can think of Twitter, Facebook, Instagram, but built on the Permaweb. And so a user on this application, they likely have a wallet. And so you can see here that the users, it points to those wallets. And in the post table, the author of the post points to that user. And you can tie topics to users from, in the bottom right, there is an interest graph application. And then in the bottom left, you can also see an e-commerce application. Within this e-commerce application, you have a product, and products similarly have topics. And so here you have products and social media posts being built on the same set of topics, both from outside their application. Similarly, you can order on this e-commerce platform, and when you order, you are ordering a product, and there is a person ordering a product. And so you can sort of see the relationships getting drawn here, that all of these, even though they're different applications, are interconnected. And right now, because of Web 2 and because of the walled-off data gardens that we live in, you can't actually interconnect these things as well as you can on the Permaweb. But if you see this structure, and you kind of followed me through that example, you can see why what we're building is called a relational database. We can give all these guarantees on data consistency and the relationships between data, and in the case of Web 3 and the Permaweb, that means that we can build very interesting relationships across different applications while also having complex data structures. How this actually works is you can take other data sets and make them a direct dependency of yours. So just like, I'm sure there's several engineers in here, Arweave is a very builder-focused community. Just like how you can install packages from NPM or pip and use that directly in your application, you can do the same thing with databases. So I've never written a cryptography library. I wouldn't call myself a cryptography expert, certainly I wouldn't build a cryptography library from scratch unless I really had to. But I use cryptography every day when I'm writing code. And that's because I can just import already made cryptography libraries and use those in my application. I just clicked back. We can do that same thing with data. And actually, blockchains, they're really good for this because they allow us to get deterministic and set times for when we are importing that data. And so it actually solves the issue of time and at what time we are importing this changing data in this data set. And so in this example here, once again, it's still a little bit abstract, and we're going to get something a bit more concrete in a second. But this shows an instance in which we have both public and permissioned applications that are building on each other's data. And when it's sort of a stream going from left to right, and when one of the data sets on the right updates, those updates will actually be reflected eventually in all of the applications to the left. And so in this way, you can build with other people's data. You have a pretty good system of timestamping to know at what point you are importing this data set, and you also get those perpetual updates. And so it creates applications that are evolving with each other's data in real time. How you actually go about doing this is with a language that we call Cuneiform. We just released this a few weeks ago. If you are a Solidity dev, this probably looks somewhat familiar to you. It's sort of based on the Remix IDE, and it's kind of like Solidity, but for building databases. If you know SQL or you're a DBA, I'm sure you could probably look at this and pretty quickly figure out what's going on here. It's a very basic application that stores users. And as you can maybe see in this users table, every user has an ID, a name, a username, and a wallet address. So very basic. And there's also what we call an index. I'm going to come back to that in a second. And then below this, we have what we call an action. And you can think of this like a smart contract function that anybody can call, interact with. It's permissionless. Or you can set rules for who's able to interact with it, but by default, it is permissionless. And this very basic action, it creates a new user. And there's a couple interesting Kwil tools we have built in. I'm not going to dive into them too much yet, but this allows you to give guarantees such as only this user is, or only this wallet is the one accessing this user, and there's only one user per wallet, and all these interesting things. This is once again, a very basic application. And then kind of coming back to at the bottom of the table there, you can see the index. So this is something that is not specific to SQL databases, and actually ARIO does a ton of work with indexing, but when we provide it in this composable data structure, it allows us to not only create new relationships, but to search through them very efficiently. And so let's go back to that example of Excel. If you had an Excel table that had 1 billion rows in it, and let's say it's these rows, and it's tracking users, and you wanted to find what user a certain wallet address corresponded to. Well, if that is unindexed, you would have to search through all 1 billion until you find your result. And an index, and for what it's worth, this is not a Kwil specific thing. This is very common in databases, but you can search through that in logarithmic time. So for all 1 billion of those rows, you only need to actually search through 29 records to find your result, and that's 29 as a maximum. And so this allows for very efficient lookup time, but not just efficient lookup time, you can customize where you have the efficiency in your lookup time. So if you're always looking up users by their address, you can put this in your application, and you're now going to scale quite literally exponentially better than if you were searching through a more unstructured data store. A special shout out to the RIO team. They're actually doing this with, and gateways in the RWeave ecosystem do this with GraphQL tags or GQL tags on RWeave. But with this, you can also set rules for how that index is updated. So you would read that structured data off of RWeave with a project like RIO. But then, let's say in the case of the hypothetical social application that we're storing users in here, you don't want a user to be able to follow a post. Users only follow users. And this is sort of where Kwil becomes handy. You can make sure that indexes are only being updated in specific circumstances, such as when it is a user's wallet address. And we can actually see this in action with a couple really interesting projects today. And so we have here, this one is brutally small. I really thought the screen was going to be bigger. But this one is the schema for Truflation. And so for those of you that don't know, Truflation, it's a massive project in the Chainlink ecosystem, and they store inflation data. So they aggregate it from all these different sources. They literally aggregate it from grocery stores, and they give you real-time inflation data, both on and off-chain. And we have here, and I can't even read this from here, so I'm sure you can't, but this is actually their schema, the full schema for calculating all inflation data, and we can implement this in Cuneiform in about 50 lines of code, which is pretty cool. And what's really cool about this is not specific to Truflation. Anything that has value, so anything that costs some amount of money, you can put into the schema, whether that is wheat or corn or barley or cars or real estate or cryptocurrency. No matter what it is, you can actually fit it into the schema, and you can do it quite easily. I mean, it's as easy as a function call, and I'm going to show this in a second. And so this is really valuable for composability. Truflation, they built this schema, they designed it, and it's now very useful for them. They've built all this tooling around it, they've built interesting queries against it to extract valuable information. But now if somebody else comes along and you also have data that has a price on it, or data for things that have prices attached to them, you can use this schema and you get a lot of functionality for free. And we show this here. So this is, we sort of call an interface over data. It's done with that same action concept that I described earlier, where there's an action that can be used for purchasing data. And so this action, if you're familiar with SQL, it is aggregating data at a specific date for something. Anything that has value, it can aggregate that data and get it back to you. And so Truflation made this. But if you are an application that now has data that has just a price attached to it, you can do this as well. And you automatically get this infrastructure and all of the data storage, all of the querying, and actually writing these queries. And any tooling on top of that is automatically baked into your application when you're conforming to their schema. I can't do like a technically live demo because the internet in here is a little shoddy. But this is a picture I took of my terminal. I did this like a couple hours ago. And it is me getting this data from Truflation. Once again, if you want these slides afterwards, feel free, but just come up to me and I'll give you these slides. But it's really easy to get this data from Truflation. And this is actually data that's deployed right now on Kwil. I believe this was corn data from, it looks like it was from April 3rd of this year that we purchased from Truflation. And it was really easy for us to do it. And now anybody, not just Truflation, but anybody that has data that has price attached to it, you can conform to the schema and you can actually start getting value for that. And that actually brings me directly into the second main benefit beyond composability of this system. Because I don't know if you caught it there, and because of the size of the screen, you might not have, but I actually had to pay for some of that data. One of the really cool things about Kwil is, and we can sort of dive into this a bit later if you guys are interested, but you can actually set prices around who is able to access data and why. If you were at the Disco Summit on, I believe it was Wednesday, Sam spent a lot of time talking about essentially putting licenses on data and guaranteeing that people are getting rewarded for data. And we've sort of taken this one step further where for your schema, you can also set rules for how people are able to interact with it. So in the case of Truflation, and they're really trying to build a decentralized data ecosystem, what they're able to do is they're able to allow anybody to upload data to their schema and get rewarded for it. So you can get rewarded in there, and to be clear, this is denominated not in our token, but in their token. And so you can upload data to the schema and get rewarded with that TFI token. And similarly, when their clients, like the Bureau of Labor Statistics or the Bank of New York Mellon or several other large institutions they work with, when them or the interface that they're interacting with is getting this data from Truflation, that money's not going to Truflation. That's going directly to that token value or to that DAO. And so in this instance, not only are we just building composable applications, but also we're able to accrue the value that is present in this data directly to Truflation's community. This is a really powerful primitive. Everyone calls, and this is a big cliche, but everyone calls data the oil of the internet. Most of Facebook's value is held in its data. But decentralized data applications are not actually getting much money from that data they're producing. And if we really want to build great incentives for posting data to these permissionless networks, we really got to figure out how to solve this. And that is exactly what we have done here. The data that exists within an ecosystem can now accrue to a token, and that's massively powerful for building sustainable economies. Now, this sits on top of the Permaweb. So the Permaweb alone is an unstructured data store. You can sort of think of it like this massive open ocean where you can put data on, and there is like a native way for tagging that so that it's easily discoverable, but it still lacks some of these data primitives that are necessary for building these building blocks. And I think that's exactly what Kwil is. You can take data from these systems that are limitlessly scalable and have tons of data on them, and you can package them into easily readable, easily understandable data building blocks that you can then put on top of each other. And just like how smart contracts, and you can use smart contracts with each other as their own little composable modules, you can do that same thing with databases on Kwil. And not only within your own application, but across different applications. And it manages the transfer of value throughout that whole process. And this is a really powerful and exciting primitive because it now not only creates new ways to build with data, but it incentivizes people to use others' data, and they don't have to go and rebuild that data moat themselves. So if you're looking to get involved in this and you're looking to build on this, the there's a number of ways to get in, and I guess actually before I dive into this, I want to make it clear that if you're passionate about this and you think what we're doing is cool and you want to see this go further, then just come and find me. Whether you want to work for Kwil, or whether you want to build on Kwil, or whether you want to build alongside Kwil, no matter what it is, the most important thing is that we're bringing in the hardest, smartest, and most passionate people to solve these problems. That's what we've done with our core team. That's what we want to do with the ecosystem as well. I think that's what the Permaweb ecosystem really is. If there's one thing I've learned in the last 2 years, it is the most nuanced and the most builder-focused ecosystem. We want to continue that. And so if you are talented, come and find us. But furthermore, Kwil is taking a very vertical approach to who we are serving. We say on our website that we are the database layer of Web3. Maybe someday we'll get there, but frankly, that's not really our priorities. Our main priority right now is to solve very hard data engineering problems for the most interesting clients. So take Truflation, for example, who is solving a very valuable problem, providing data in ways that could not be provided before, and they get better accuracy than virtually any other institution that has been established for tens or even hundreds of years, and they've only existed for about 2 years. That is disruption. That is very powerful, and that is the type of use case that we are looking to enable. And so when you're building on Kwil, you're not just building on an awesome database, but we're also here to help you with your go-to-market. We're here to help you with fundraising. We're here to help you build and design your product and find customers. Just like how when you are building on the Arweave ecosystem, you're not a client of Arweave. You are now an extension of Arweave. It is the same thing with Kwil. When you're building on Kwil, you're an extension of Kwil, and vice versa, Kwil is an extension of you. We're a protocol that allows you to leverage your data in new ways and build new amazing applications. And so that means that in every sense, not just the data infrastructure sense, we are working with you to make change and to build the best product that you can. And now I really want to keep this topic short. The most interesting thing about these conferences is talking to you. I can kind of sit up here and talk to you all day, but you can also find videos of me doing this on YouTube. The most interesting thing is trying to figuring out what we're going to do to unlock these new and amazing applications that are possible on these new data primitives. And so at this point, actually, I would kind of like to spend the rest of my time either opening up for questions.
I was just curious, is the index and things like that on the chain as well, or is that through your service?
So it's through Kwil. So you can sort of view Kwil as a layer on top of Arweave. The reason we can't put it on like Arweave itself, so the reason Arweave scales so well is because it's a large, eventually consistent protocol. That's why that's why you can't really top out the size of Arweave. You can top out the size of a relational database. Now we're working to continue to expand that, but yes, the index is held on the layer 2 so that each module is only limited by its own scalability instead of them limiting each other's.
Thank you for sharing. I was just curious, when you commit data to Arweave, do you do so each row or each interaction one by one as ANS 104 data entries, or do you do them in batches?
Batches. So we can sort of think of, and for what it's worth, it runs on one system, but the incentives of the Kwil system sort of are in 2 layers. So we see event sourcing and consistency as one, and then the actual engine as the other. So for any people that are familiar with traditional data infrastructure, think of Apache Kafka or something like that, where we can get strongly consistent event data that we can then read from. I would say this is fairly similar to existing like blockchain infrastructure, but the big key here, and this is actually where it's very different from the consensus Arweave provides, is that it's strongly consistent. So when data is committed, it's committed. There's no soft fork. And there are some technicalities of relational databases why we have to do it that way. But so when data is getting processed from that upper layer and getting pushed down to the database layer, we're trying to get that to be about 3 seconds now, but it does sort of depend on how permissioned or permissionless each database is. That data is then able to get stored on Arweave.
Thank you, Brennan. I absolutely love what you guys are doing. Question though, and I guess maybe this is something that like the Kwil layer does, but if I want to load all of the rows in the database, do I have to like replay every single transaction made, or does Kwil kind of roll that up and have like the state or like, yeah, kind of the sum of all the changes, so it's really fast for someone to get the latest version of that database?
Yeah, that's a really good question. Right now, you do sort of have to replay everything. Now, doing it in batch is much quicker than doing it one at a time, and we can do it in batch. But actually, a really cool innovation that we've made, and we have not rolled this out, but it does work. They're called change sets. This is pretty deep into actual like relational database lore, I guess. But it's a binary representation of one state from one state to another. So instead of going from A to B to C to D to E, you can just go straight from A to E, and you don't need all those intermediate steps. We actually support that at the database engine level right now, but we have not rolled that out to the network level yet.